Hey folks, Bob Barker here, and this calculus lesson is on velocity applications. Let's go ahead and begin. All right, remember rate is just distance divided by time, and there's two types of rate problems. Rate is also derivative. So one is this, you guys, the average velocity. The average velocity occurs over an interval, which means you have two coordinates. Remember, s is your position function, and t is at a specific time right here. So this says velocity. Your average velocity is s of t2 minus s of t1 over t2 minus t1. S is your position function and t is time. Instantaneous velocity occurs at a specific time, and that means you got to take the derivative. Okay, and it's easy enough. Let's go ahead and try. So notice that part A has a start time and an end time, and then part B is specifically when a time is. Okay, so speed is always positive. Velocity equals speed, but sometimes your speed is going up or down, or sometimes it's going to the left or to the right. So it's positive if it's going up or to the right, and it's negative if it's going left or down. All right, let's try one of these, actually a couple of these, okay? So for a ball that's dropped from 100 feet, its height s at time t is given by the position function. S of t equals negative 16t squared plus 100. Find the average velocity over the interval 1, 2, so these are in seconds, 1 second to 2 seconds, and find the instantaneous velocity at the time t equals 1.4 seconds. All right, so let's go ahead and use our definition of velocity average. So I do s of t2 minus s of t1, and I did that up here. Here's t2 is 36, t1 is 84. So then I get 36 minus 84 over 2 minus 1. Notice it's negative. Well, it's negative because it's going down. So it's negative 48 feet per second. Always put it in the context of the problem. So we're dealing with feet and seconds here. Okay, so negative 48 feet per second. All right, instantaneous means I got to find the derivative. So if this is my position function, then its derivative is negative 32t. And then you just plug in what they're asking you to at instantaneously 1.4. So you plug in 1.4. And you get negative 44.8 feet per second. Now these should be close to each other, and your AP readers, if you're taking the AP test, want you to recognize that those numbers should be close to each other. All right, so let's try another one. So at time t equals 0, a diver jumps from a platform 32 feet above the water. Her position is given by the position function, s of t equals negative 16t squared plus 16t plus 32. So when does the diver hit water? When is the velocity, what's the diver's velocity at impact? So this would be instantaneous. That would mean the derivative. All right, for this one, when does the diver hit water? Here's a groovy picture, you guys. There's my diver up there. Okay, so she's going to dive off, and then so when she hits the water, she's going to be down here. Her height is going to be at 0. So this is my position function, so this is my height right here. So I'm going to set this equal to 0. That's when she's going to hit water, is when her height is at 0. So go ahead and, oh, and your book might say S sub 0 is your initial position and V sub 0 is your initial velocity. So just watch out. You might see that in your textbook, okay? So when she hits the water, you set it equals 0 and solve. Go ahead and pull a negative 16 out, and then factor that, you guys, and then set this factor equal to 0 and this factor equal to 0, and you get 2 seconds or negative 1 second. Well, she can't be in the air for negative 1 second, so you can disregard that. So she's going to hit the water after 2 seconds, okay? And then, so what is the velocity at impact? Okay, so after 2 seconds, so you're going to plug in t equals 2 into the derivative. So there's the derivative right there. Plug in t equals 2, and I get negative 48 feet per second. Okay, and so just try to have it in the context of the problem. Try to answer it to what it's asking for. So our velocity at the impact is negative 48 feet per second. And if you were in my calculus class, I would assign that for your homework. Take care.